Okay, good morning. Linear equations with two variables. An infinite number of solutions. For every sort of input value you might put into this equation, you get a corresponding output value. X's and Y's, ordered pairs. So our job today is to just find points when we have an equation and use those points to graph those equations. And so just starting with, I got a bunch of examples we'll go through and we talk about a couple unusual cases always. And then you luckily might actually get to 4.3, which really is is not really going to add much to what we're covering right now. So for instance, we'll see how this works, right? How far over can I make this work here? I'm checking to see how that looks. A little glarier, this piece of plastic that I have over the top, a little more glare. Make sure it works. So here I have 2x plus 3y equals 6. I want to find at least 2 points. I need 2 good points to put on my graph, and then I can connect the dots. Let's just do some little housekeeping. I'll say this is my x and this is my y, and I'll say that all my units are one unit apart, all my lines. So in this case, we're just trying to make one of these T-charts, basically, and plug in a couple easy to use numbers. Hopefully we can think of something that, a couple numbers that are convenient, not too messy. If we can avoid fractions, it's usually better because otherwise we're guessing between the lines. Here's one of those, we call this standard form. When the equation's in this shape, both x's and y's on one side. But here's that equation in that particular shape. And yes, just kind of cheating, looking ahead. The 2 and the 3 would work as divisors of 6, which makes putting in zeros for an x and a 0 for a y, and see what we get for the other variable value. Makes those pretty convenient. So if I put in a 0 for the x, here's what I say, there's my cover-up math, right? 2 times 0 plus 3y equals 6. I'm going to be a little abbreviated here, but if I do something that's confusing, stop me. So that's a 0. I have 3y equals 6. I divide by 3, I hope you're okay, that y would equal a 2. That's what I mean by being abbreviated, not quite showing every little step. We're experts at these equations now, right? If I put in a 0 for the y, right, that's a 0, so I get 2x equals 6. 2x equals 6, that cancels out, right? That's a 0. Dividing by the 2, I get x equals 3. So there are 2 points. They're in that table, but hopefully you can see how those would just be 2 ordered pairs like that. Okay. So 2 points to put on the graph. 0 for x and 2 for y. And 3 for x and 0 for y. So I've got 2 points like that. Connect the dots. I think mom almost makes you connect the dots with this sort of pencil tool. But I remember students doing tests by hand. Sometimes they would put their dots on and then not connect the dots and not show the whole line. So that gets a little messy because I'm trying to maybe squeeze in too much stuff. But there I found 2 points that are solutions to this equation, and graph them, connect the dots, and now shows me all the possibilities, all the possible combinations. Something out here, I figure out what those coordinates are and plug them in. I mentioned 4.3, that section is entitled Graphing Using the Intercepts. Well, we just did that. I found the x-intercept by plugging in a y for 0, And I found the y-intercept by plugging in a 0 for the x value. If I said that correctly, right? But I found the two places where the graph of this line, the graph of this equation, crossed the axes. Those are the intercepts. Those are two convenient places to find points, especially when the equation's in that shape, standard form. All right. Well, keep going. Y equals 3x minus 1. All right, the other shape. We'll have a special name for that come Monday, probably. We'll talk about what those numbers in there mean. So, same idea here. I'm going to pick some numbers to plug in there. And this is the one where I usually say it's easiest if we pick some x values, some nice x numbers to work with, and do all the calculation basically on the right side of that equation, and then we'll get the y that comes out as a result. So here I usually just pick a couple numbers. The 0 often works anyway, right? But I just chose a couple others. No good reason. So if I put in a -1 for x, looks like I get a -4. Excuse me. A -4 for the y. All right. If I put in a +1 for the x, and see if that we can make this work over here. Three minus 1, I'll get a y equals 2. All right. Two ordered pairs. Just to emphasize, be careful if an answer requests, says express as an ordered pair, you gotta do the parentheses and the comma, and don't just write one of the numbers. Got to put them both in there, right? So let's see. Graphing it now, I've got 2 points. -1, -4. 1, 2, 3, 4. Oh, my line's probably barely visible there. I make it bigger. And x is a 1, I'm up at 2. So there are 2 points for that equation. Connect the dots. So graph paper is nice here. Now hopefully makes it neater. You could more easily find other points. It's like, maybe there's another one right there. All right. Notice I put arrows on the end of that line. It implies that it goes on forever. Any x value I choose would eventually have a y value that goes with it. Even something like here being very, very negative. Any x value, even a fraction, an irrational number, I plug in. That line goes on forever. So that's what we're doing, a bunch of that. Okay. So here we go. I'm going to back up, erase over here, do it again. Hey, all right, I like that. Yeah. -2x doesn't matter much. Let's say +4, huh? Okay. Another one in that other form. So I'm going to pick some x's. About a 1 and a 0. All right, just 2 easy numbers to plug in. If x is a 1, y equals -2 times 1 plus 4. -2 plus 4, I'm solving now, right? And so y equals 2. 1, 2. If I put in a 0 for the x, -2 times 0 plus 4. Well, I'm just going to get y equals 4. Now I'm writing over the top of my graph, so if that work makes sense, hope you're okay with that. I'm going to erase that work there so I can put my points on the graph. Need to make myself one of those grids, I guess, where it's blank on one side. Oh well. 1 and 2. X is a 1, y is a 2. X is a 0, y is a 4. 1, 2, 3, 4. Right. So, all my 2 points. And connect my dots. So, nothing hopefully tricky about that at this point. Finding, the fact that they're integer values makes choosing numbers kind of easy. You can pick any X values you want. For some reason, if I had a reason to pick a big number, I could. How about that one? Just y equals 4x. There's nothing extra after it. Oh well. It kind of means something. Once you get familiar with it. Pick a couple numbers, right? How about a -1 and a 0? Just picking a couple x values to put in. All right. So if I picked a -1, I get y equals 4 times -1. Y is a -4. If I pick a 0 for the x, y equals 4 times 0, y is a 0. 0, 0. Put them on the graph. -1, my numbers on here. -1, -4, 1, 2, 3, 4, and 0, 0. That point, the 0, 0, that's what happens if there's never anything extra added or subtracted from this shape, right? We start thinking ahead. Notice that if x is a 0 here, I'm at this 4. That 4, the extra number, actually kind of takes this shape and moves it up or down. +4 in this case, or here it didn't go up or down at all, so it's going right through the origin. Just recognize, trying to point out, start recognizing some patterns like that. As long as we're talking about patterns, as long as I mentioned it, notice this one, we kind of think left or right. This one's going downhill, right? It's going downhill. This one's going uphill. That's the deal. That's a concept we'll talk about next time. It's called the slope, right? How steep is that hill? The slope. Well, the sign on the x term is going to determine that direction. This is a negative number. We're going downhill. This is a positive number. We're going uphill. Just getting ready, thinking about what those numbers mean in the equation shape here. Getting ahead of ourselves a little, but all right. Check, make sure nobody's fleeting. No, looks good. Another version of that, this is basically the simplest linear equation. Y equals x. Whatever I put in for x, I get the same for y. All right. 0, 0, 1, 1, -1, -1, 5, 5. So just like that one, if I put in a 0, I get a 0. If I put in a 1, I get a 1. Let's say if I put in a 3, I'd get a 3. That one gives us just this sort of diagonal, 45-degree-ish. Going back to geometry. Don't worry, we're not going to figure out the angles of these lines. But that's what that one looks like. So again, just sort of recognizing patterns. That was a 1x You know, whatever I put in for x, I multiply only by 1. I didn't really change it, right? And that's what the y I got. Here I got 4. Whatever I put in, I multiply by 4. That makes that line, you might say, 4 times as steep. When we talk about the slope eventually, that was a steeper line. But we're just trying to graph right now. Plug in some points. Well, and whoops, drop it back. Ugh. All right, this one has a fraction in there on that x value. Well, I still need to plug in some numbers and find a couple points. So here's my recommendation, right? I still want to pick some x's. It's going to be easier still to plug something in for x and do the work on the right side, generally. Pick a number that's a multiple of 3. That'll make the fraction cancel out. Pick some nice numbers that work well with the 3, like maybe a -3 or a 0 still works, right? Or a +3 or a 6 or a 9. All right, so I'm picking numbers that are multiples of the denominator. So now when I plug one in, let's put that -3 in there, for instance, right? Y equals 1/3 times -3 minus 2. So the 3's cancel. That's going to be -1 minus 2. Oh, just happened to be -3. That total coincidence there. Okay. Kind of like working off to the side like that. I'm going to try that over here. If I put in a 0, well, if I put in a 0, that one's easy here, right? Y equals 1/3 times 0 minus 2. Y equals -2. Y equals -2. And if I put in the +3, 1/3 times 3 minus 2. Again, the 3's cancel, so now I just have a 1. 1 minus 2. Y equals a -1. I did three numbers just to show that they all worked with that denominator. -3, -3. There. 0, -2. And 3, -1. 1, 2, 3, -1. All right. So did that pretty well to make all my dots line up. I was talking about how steep one line was versus the other. 4x versus 1x. So here's a 1/3. Notice it's a smaller fraction number, right? It's more shallow. It's not as steep. Again, recognizing patterns, getting a little ahead of ourselves. Then we have to start talking about calculating it next time. So I'll spread out that time, but hope that's okay. So dealing with fractions, pick some numbers that work well with that denominator value. Nice thing about that other form, that standard form where the ax plus by equals c, sort of one of the definitions of that form eventually is that no fractions in it. You make them all big enough so that you get rid of the fractions, so you won't see fractions in that one. Just one more of these. Here's another fraction one, okay? -1/4 x plus 2. Pick some good multiples of 4. Again, you know, -4 or a 0 or a 4. 8s, 12s, 6, and so on. Excuse me. Plugging those in for the x value. If I put in the -4, like -4/1, right? Well, 4's cancel, but I do have negative times negative, so I get a +1 plus a 2, y equals 3. If I put in the 0, y equals whatever times 0, y equals 2. And finally, if I put in that 4, right? Here the 4's cancel out, but I do have negative times positive, so I have -1 plus 2. I get 1. I'm going faster than you might. That's okay. I hope I just slow me down if I get ahead of you. Oh, I've got my points again. All my work is here. I'm going to get rid of it so I can graph that, okay? I'm going to erase my calculations here. So let's see, -4x, 1, 2, 3, 4, and 3 for y. 0 for x and 2 for y. 4 for x, 1, 2, 3, 4, and 1 for y. All right, good. They look like how they're online to me. And that number on the x was a fraction again, less than 1. Notice it's kind of shallow. And there's that negative sign I was talking about before. That means this one's going to go downhill. Right? Negative slope. All right. How about another one of those? All right. Standard form, x and y both on one side equals some other number. Oh, look, that'll divide nicely into 4. Let's try the zeros. I'm really graphing using the intercepts. That's what 4.3, section 4.3 is called, graphing using the intercepts. We'll do a little more work there. What do they mean? If I put in a 0 for the x, can I just say 0 plus y equals 4? You get y equals 4. All right, 2 times 0. I put in a 0 for the y. I just get that 2x equals 4. I'm really getting lazy here. Make sure I don't lose you there. Probably should have written that one out before. Hopefully it makes sense. Let's see. Well, let's see. Did I do that right? Yeah. So 0, 4, 1, 2, 3, 4, and 2, 0. Connect the dots. All right, here we go. A couple weird ones. I'm going to claim that's the equation of a line. X equals 3. Where's the y? Well, this equation doesn't have a y in it. It doesn't depend on the y value or vice versa. No matter what value I could think of for a y number, whatever y is, x is always 3. That's what this is saying. X is always 3. X is always 3. Special one, right? Vertical line. Now these are a couple we're going to talk about. What's the other one, right? Vertical versus, that'll be the next one. And then these two equation shapes boil down to we'll see, oops, do that a little bit. That's what a vertical line equation looks like. All right. Now we're going to talk about how steep is that. Well, it's straight up. How do we describe that? We're going to say, well, it's undefined. It's so steep, it's undefined as far as how steep that is. But there's what the equation of a vertical line looks like. What is the x value it goes through? That's all you're going to see for that vertical line. So what about this? Y equals -1. Interpret it the same way. No matter what x value you might imagine, or whatever the situation is, the y value is always -1. There is the equation of a horizontal line, right? Somehow or other, no matter how hard I try, somebody gets mixed up which one was which. So hopefully you can kind of think it through. You know, what does it mean? Y is always -1. Well, put a -1 on a bunch of x, you know, no matter what x is, y is always -1. This kind now, we'll see, we can actually think of that number that's attached to the x as 0. We can make it look like that other equation shape. This one, we can't really do anything with that. This one is stuck, x equals whatever, vertical. Here we can say, oh, I'm going to put a 0 on the x and it's going to go away. So why bother? But that number is going to relate to how steep is that line. Well, how steep is that line? How much is it slanting? Not at all. All right? It's level. No slope. No slope. That's what that number is going to mean. How steep is that line? All right, vertical and horizontal. A couple weird ones. Notice that's not the same as y equals -1 x. This one has an x and a y. This is one of those where there's no extra plus minus number on the end. So it is going to go through the origin. But if I put in some x value, I can plug in any number for x I want. I'm going to basically multiply by -1 and change its sign. So picking some numbers. If I put in a 2 for x, I'm going to get a -2 for y. So if I put in a 0 for x, I'm going to get a 0 for y. If I put in a -2 for x, I get a negative times negative, I get a +2. So this is, remember we did that one where, you know, y equals x, it's just at 45 degrees. This is the negative version of that. 0, 2, -2, and I'll sketch that one here. Whoops. All right, straight line. But my point there after those last two examples was, it looks like a real simple one. Is that just horizontal? No, this one still depends on what you put in for x. It's just saying the slope. We have a negative slope. All right. If I have a point here, all right, what are the coordinates? Well, the x value, what have I do? 1, 2, 3, 4, 5, 6. What's the y value? 0. Anything special about that point? It's on the x-axis. Is the x-intercept. Intersect, I wish. I have one over here. What are its coordinates? Well, the x value, I haven't gone left or right, it's a 0, but I'm up at 3. What's special? It's on the y-axis. It is the y-intercept. We abbreviate y-int, x-int. See that eventually. Start doing that. These 2 points are intercepts. They're intersecting the graph. They're points on the axes. Mentioned this before. The y-intercept, the other letter, the other variable is always a 0. Y-intercept means x is 0. X-intercept means y is 0. If you can read, hopefully you can sort of reason that out and it's not just a memorized pattern. If I'm on the y-axis, close my eyes, right? If I'm on the y-axis, I haven't moved left or right, x is 0. If I'm on the x-axis, I haven't gone up or down. The y is 0. All right, so I've already mentioned we've been doing it, graphing using intercepts. Three x plus 4, y equals 12. Find the x and y intercepts for this equation and graph. You see instructions, something similar like that. Find the intercepts. Use the intercepts to graph this equation. How do I find the intercepts? You'll put in a 0. If I put in a 0 for x, I'm finding the y-intercept. If I put in a 0 for y, I'm finding the x-intercept. This is 4.3. 0 for x. Y equals 3. 0 for y. X equals 4. 0, 3, 4, 0, 1, 2, 3, 4. Dusty or something here. I just graphed it using the intercepts. Excuse me. I kind of looked through all your mom problems. Any of them that are in the standard form, they're giving you nice numbers that divide nicely over there. So this 0 method works well. I'll make up one though that doesn't, just to show that it could happen, right? Excuse me, graph it using the intercepts. Find the intercepts to graph it. And if x is a 0, divide by -3, y would be a -5. Again, hoping maybe you're keeping up with a little bit I'm doing in my head. If y is a 0, y is a 0, that whole thing becomes a 0, all right? 3 times 0. So dividing both sides by the 5, I get x is a 3. Did I do that? I wrote -5, but here I put a -3. I was kind of getting ahead of myself. Whoops, I knew something was wrong. There, we fixed that one. What, you guys are yelling and screaming and catching my mistakes? That's all right. Luckily I did. 0, -5. 1, 2, 3, 4, 5, and 3, 0. 1, 2, 3. There are 2 points. You'll allow that I could connect those dots, graph that line. All right. If I had something like that. Yeah, those don't divide evenly into that. But I could still find the intercepts. They're just going to be fractions. They would be fractions for that equation. I still want to put in the zeros. That one value is still going to be a 0 if it's an intercept. So if x is a 0, I get 2 times 0 minus 5y equals 7. That goes away. I'm going to divide by -5. You get that y is a -7/5. 0 for x and a -7/5. Well, let's see, 5/5 would be 1, so 1 2/5. So 0 for x, negative roughly there. All right? That's what's the, well, and you can't even see with my little dots on the screen there, perhaps. Sorry. If I put in a 0 for y, that cancels out, that's 0. 2x is 7, so if I divide by the 2, x is 7 halves. Let's see, 6 halves is 3, so 3.5. 3.5, 1, 2, 3.5. So there would be the intercepts there. Visual estimates of where those fractions would fall between the integer values there on my number lines. So it could happen. Hopefully it doesn't happen too often. It probably won't happen hardly at all for you. All right? Well, so what? So we found the intercepts. And we can use those 2 points to kind of conveniently graph our problem. I'm going to kind of make up a word problem here. And I'm going to say, this time my x-axis stands for time, t for time. And my y-axis is going to be miles. I'm just going to make up a graph here. And there's 1,000 miles. And let's say time in days, all right? That's up there on 1,000, okay? Squeeze it in. I'll make that a little easier to read. Read the graph. What are the intercepts of this line? What are the intercepts? You'll be asked to do this. Look at the graph and what are the coordinates for the intercepts? Well, going through that point, what's the x? I'm on the y-axis. What's the x? 0, 1,000. All right. Here, my x is 5. But my y value is 0. I said I was making up a word problem. I'm imagining I'm taking a trip. I'm describing a trip, right? And I started 1,000 miles from home. And this graph describes how long it took me to get home, or how far away from home I was on any given day. This graph describes how far I am from home. So the questions you get asked relate to the intercepts. How far away from home were you when you started? When you started. Where are you on the graph when you start this problem? I'm on the y-axis. Time-wise, right? Time is what I'm sort of keeping track of. That's my x-axis here. When I start, I'm here at the beginning. Here, the intercept describes the value in this problem when I start. I'm 1,000 miles from home when I start. How long will it take before you are home? Or your distance from home is 0. Oh, that's the other intercept. When is that value reduced to 0? 5 days in this problem. Here I'm interpreting the intercepts. What do they mean in the context of this problem I kind of made up after the fact, right? In general, your y-axis refers to your starting value, and then as you progress through more x values or time, or you purchase more items or something, your x-intercept refers to when you get down to 0. If it exists. Sometimes it doesn't exist, right? My plumber problem from, was it just yesterday? No. Plumber charges me $80 to show up and $40 an hour for every hour he works. What are the intercepts in this graph? Well, all right, that one hopefully is clear from my drawing. And the x value or the time value is 0, right? How long has this person worked? None yet. But the value, the cost is $80. Where's my other intercept? No, look at that line. Let's see if I could squeeze it in somehow. It'd be way back up here. It'd be some negative number, but the y value would be 0. Now, in the context of my word problem I made up, does it make any sense? They're going to pay me for not showing up? Something like that. Or he works a negative number of hours. It just doesn't apply. So really, the model really only makes sense over here, quadrant 1. In fact, you'll probably see a mom question. Why only quadrant 1? Well, because you're only going to ever use positive values for x, and you're going to get positive values for y. Many physical dimensions or real world problems actually only really happen in quadrant 1. Everything is a positive time value or a positive number of items purchased, and then a positive amount of money you have to pay or something like that. But I can still ask an interpretive question. What does the y-intercept mean in this problem? All right, the y-intercept means you're going to pay $80 whether he does anything or not, shows up. He shows up, and it's going to cost you $80, no matter how long. And that's the starting minimum fixed amount. Another, I think I mentioned this in the previous chapter, we used to do phone problems similar to this, where you pay $25 fee, and let's say 10 cents per minute for long distance or something. So you have phones used to run that way. You had a month for long distance. You had basically an access charge to long distance, your fixed amount, and then for every minute you were on long distance call, you had to pay something. So here's my $25 fee, and then it goes up depending on how many minutes I actually use. What does that, again, the model really doesn't apply. Negative minutes, we give you money back, maybe they do that these days. But what does that intercept represent? Well, if I have the plan at all, right? If I have purchased the plan, I'm going to pay that $25 a month, even if I use 0 time. So the minimum charge, the starting value, 25. So your y-axis is usually your starting value in the problem. if you get one that has a negative slope, like that first one I made up, that first one, like something is going down in value, a population problem you might see where some towns started here at this population with 1 year, and after 10 years it was down for population. Let's hope they don't become a ghost town, but here's how much the population was at a certain starting point, and eventually for some reason it's down to 0 after some other period of time. If you get a negative slope, then more often we can see X and Y intercepts that make sense in the context of the problem. A little crooked. All right, what are the intercepts for that line? Horizontal line, sort of. And what are the coordinates of the intercepts? Well, there's a spot right there. Right? X is 0, Y is 3. There is the Y-intercept value. What are the coordinates of the X-intercept? Well, if it's a horizontal line parallel to the X-axis, it's never going to cross. Does not exist. Mom will ask you to do that. X-intercept does not exist. Never happens. You want to say conversely, right? All the way around. Vertical line. What are the intercepts? Well, here I have -4, 0 for my X-intercept. I'm going to slow, make sure I don't mix those up. But where's my Y-intercept? If it's vertical, it's parallel to that Y-axis. So the Y-intercept does not exist. There's a couple special ones like that. Right on time. You know, we just went through 4.3. 4.2 and 4.3, we did that today. I knew 4. I forgot when I scheduled, you know, laying out the whole term, didn't want to squeeze things in, but I usually do these two together. 4.2 and 4.3 go together because we're really using that, use the zeros, find the intercepts a lot, even before they talk about it. So I get through them both, which is good in the future. You know, I have more time for the later stuff, which always gets a little more complicated. So that's it today. 4.2, and you're ready for 4.3 Thursday. All right, enjoy your weekend. Some of you are already getting your hand-in homework done. Really, like I said, kind of like last chapter, hand-in homework. But get that done. Ask me questions if you've got anything, any problems, any concerns. All right. Well, good. Have a nice weekend, and I'll see you on Monday, and we'll get into details about how steep that line is. Yes, thank you. See you later.
Thanks, Steve. Yeah.
Bye.